Good morning, everyone. So the abstract, how do we cook systemd, and I'm not trying to pose as a systemd expert. There has been enough on the FOSDEM for the last couple of days, so if you had systemd related questions, they should have been addressed there. I'll try to cover the Yocto part only. And if I'm saying complete nonsense, please correct me somewhere. So this is just my view how we should do it in the Yocto sense. Short about myself, I'm Vyacheslav Yurkov. I usually go just with the name Slava so that everybody knows me with that name. It's simpler for everybody to pronounce. I've been using Linux since 2000, and I've been regular contributor to various open source projects. Linux kernel, trusted firmware A, also Yocto project, and I try to maintain what is related to overlayfs in OE core and also the overlayfs user space tools. So not the kernel part, but the user space. And last year I founded my own company to start my own journey, because I usually work not that long for various companies. So meet OSS keeper, so kind of official announcements, and yeah, I try to have my way with that name. Thank you. So that's a brief agenda. Let's try to follow that. What is systemd? How we build that in Yocto? How we use it in Yocto with the other user software? And thanks to my reviewers of the slide, how can we do it better? So the motivation for that talk is actually came from last year. Ross had a nice presentation on Yocto Project Summit about best practices, and I thought, okay, but we should also cover the systemd part, and that's why I wanted to present that. Here the links, Ross's talk, and also Alexandra has a nice collection of best practices. There are many more talks, but what I checked, I think none of them covers the systemd part, although many people here find it obvious how to do that. So now a question, what is systemd?
Everything.
Or what is systemd not? What do you like better? That works too. So for me, that was always, that's an init manager. But I think it's much more than that. They have a bootloader now. They have a log manager, which everybody uses, like a journal D. They have network configurations who do everything with systemd, session manager, and many, many more other servers. I think Leonard mentioned in his talk, there's about 150, 149 executables right now. Yeah, so all that is systemd. So that's like official definition you find on systemd.io. So it's a suite of basic building blocks which you use, and it includes all that. I'm not going to read that out. Right. So how do we use it in Yocto? So since I think Kirkstone, it became quite simple. You just set init manager to systemd in your distro configuration, and that should handle the rest. This actually translates from the couple of includes. We have in the OE core the init manager. So that's the one you assigned before, the systemd. There are a couple of them. And this one includes by default bitbake configuration. So this in turn, the init manager systemd has all that set. What you use as init scripts, what you have as login manager, and etc. I think before Kirkstone, you should have done that manually. So I think that's improved only in Kirkstone, that you now set only the init manager and you're good. Right, so systemd as a bootloader. How many of you used it actually? I counted 2. I think that's mostly 3, 2.5. I think that's mostly a UEFI bootloader. So I'm not sure if you can actually use it on ARM platforms. Maybe you can. Fair point. It was originally the standalone project called Gummiboot and was merged at some point completely to systemd. It shortly was called SD-boot. So I tried just to build it. I think it's enough to send your E5 provider to systemd boot in your machine configuration. And the rest, at least in this Kafka build, I didn't check before. It's enough to set that and you're good to go. Yeah, of course you have to provide your own configuration after that, how you want to configure that. Now let's see the build workflow, how we build systemd. So normally when you build images or any other software, you have your host toolchain, or you have all the required packages when you see in the manual, which you have to install. That includes, for example, build systems like CMake or Meson. And then you build native packages which are going to be run during the build to build across toolchain and to build the target packages. So far sounds correct, right? Yeah. With systemd it's a bit different because we do not need the native systemd in a system. We have it already on the host, and when we build systemd, we still need a couple of binaries that you run on the host. The good example of them is systemd boot native. I think it uses UKFI script from systemd, which is supposed to run to create UKI kernel image. And you use system control to enable disable services. I think it's done either on the first boot, or if you use a read-only rootfs, then you need a system control to run the later stage when you create a rootfs. Yeah, but we don't need the full-blown systemd as a native package because it will conflict with the host system. So how do we use it in our recipes? So if we have, so usual way would be you have some systemd units. You want to start your software automatically, and then you have a service file. So you usually inherit a systemd class, and you set systemd service to your service file name. So by default, that means that service is going to be started, and you just install it to the systemd unit directory, this one. There is a possibility to separate systemd service files or units to a separate package. Some recipes do that. Otherwise, by default, it goes to the main package. And like I said, by default, those units are enabled. So you can specifically say, OK, but it's going to be disabled until user doing otherwise. So that's another example what you can do. So assuming you want to start some software not as part of your particular application package, but on a system level, so when the system boots up. So I saw people doing that. They simply create a BB append for the systemd and then start those services. Don't do that, because that that looks scary.
Yes.
Yeah, but I saw in real project people doing that. So why don't do that? Because you can have so much dependency links that the whole systemd rebuilds, and that takes ages because that brings a lot of more dependencies, a lot of services depend on systemd. That's an example I had in the real project. We had a Qt application which we wanted to start at a boot time, and so in a layer we had just the BB append to systemd, and that Qt application depended on Qt Web Engine on my build server, about 48 cores, 120 gigs of RAM. That took like 45 minutes to build. And of course, all the rest.
Because even if you had Qt web engine built previously,
It will rebuild. Yeah.
we had that nature.
Oh, yeah. So what you should do instead, you can create a dedicated recipe for that. Let's call my project systemd units, whatever, and install them there and put it as a dependency or as an image install in your image recipe. Or you can create a BB append for the recipe which already exists in OA core, which is systemd machine units, and do the installation there. So that's, I find both ways work. Depends how you need to split your units. Maybe you need different packages and having them all in one BB append is not that practical, but both ways work.
There's systemd conf also, isn't it?
This one.
Oh.
Yes. For the configuration, there's a systemd conf. What goes there by default is network configuration and drop-ins for different systemd services like journald, login, and usually those drop-ins have higher precedence than the default configuration. So if you need to change some default values, it's better to use drop-ins rather than replacing them in systemd. Although there are some cases, I'm not sure if I mentioned it in the slides, but I faced recently some cases you still need to change the default one. Maybe I'm wrong here. Like I said, I don't remember if I included it in the slides, but one case I saw where the unit is part of a systemd itself and you need to change this configuration. I'm not sure if you have any other option rather than modifying the...
Drop in for a unit.
So the unit config itself.
Yeah.
You have a drop-in for...
Drop-ins for units.
Okay, so you have that. Okay, I didn't know that. That's cool.
There's also systemd overrides that you can put in Etsy systemd overrides something or other.
So you can override a default unit.
Yes, if the unit file in Etsy, takes precedence over one in usual.
Okay.
And systemd installs its
In lib,
user,
yeah, in
so
user,
you can
yeah.
put one in etcd.
Okay, okay, makes sense. Cool, thanks. That's an example how you do a network configuration, for example, for CAN or for the Wi-Fi and or for whatever other network configuration you have. So you just create a BB append for systemd conf and install them there. Yes, so that would be the way I still find the only way you can do is to create a BB append for systemd. If you really need to switch off some services completely, you just modify package config. That's, I think, the best option. You either append or remove a package config, because if you check the systemd recipe, I didn't count, but it has like 30, 40 different package config flags, maybe more. Yeah. So I think that would be the only way to do. So no other way than creating a BB append. But that thing you don't do daily, so you do that once, twice when you tweak the system. Right. Okay. Any other questions, remarks? Maybe I missed anything. I didn't touch, there was a, I think, Getty recipe for systemd. I didn't touch that. That get TTY recipe.
You could also, you say there's no other way, you would put these as a PN whatever, PN systemd in your distro configuration, because you might have two distros, one with network D, one without it. I do this, so yeah, you could do that as well.
I heard some doubts. So,
Maybe repeat it.
so I think the suggestion was to put different PNs in your distro conf.
No, you can put the package config append as a systemd override in your distro configuration. So you don't. In this case, it would give the same,
Yeah.
but it would give you the option to have two different versions of systemd.
With the two distros then.
Yeah, but then it would be another distro then.
But
Yeah.
also
Yeah. So if
logically you could say
basically
that
the
this is a
suggestion is like you
it's a
can have
physical
different distros and then based on the distro you have a different configuration of the systemd. Yeah. Okay. So let's see what new we have or what we can do better. So I think last week, no, the week before, so end of January, Artur Kowalski created a patch set, the big set, I think 8 patches, which landed in master last week. Now you can have user units for systemd. So by default, what happened is the systemd class placed all your units under the system space. So now we can handle also user units. So sometimes I think it's practical when you don't want to run everything from the super user. You just have units based on a specific user. What else we can do? Let's see. We have right now a systemd system control native recipe. What it does is basically re-implement the system control from systemd as a Python script. Can we do better? I think we might. So thanks to Richard, we actually have in systemd they started using install tags from Meson. So I think Meson had that feature for about like 2-3 years already, where you can specify what you actually can install. And I sent a patch to systemd yesterday, and I think it was approved just an hour ago, where we can just install system control. And this patch series over here is a proposal to replace the system control with the native build. So basically what you do is just you check out the systemd you're going to use and you build only system control. No Python script anymore, no reimplementation, and always in sync with the upstream. Let's see if you like it. The few catches here that we had to extend the bitback configuration because the native systemd build requires getEnt utility from libcutils, so that's the only catch. So that's one thing. The other thing, when I mentioned that you can set your init manager as init manager equals systemd, but you all know Poky, and the argument we had yesterday that not many people distinguish what the Poky and Yocto is. So the Poky is a reference distribution which you should not use in your products, and Marta will back me up here after me. But the default init manager for Poky is not systemd, and I had a quick exchange with a few people. And Richard told me, so the main reason for that is actually because we have about 25 patches in OA core to add support for muscle, because in Yocto we want to support different C library implementation. And I think many people participated in that and tried to make them upstream, and not all systemd maintainers were happy with them. What I also noticed that Anna Wilfox, I also exchanged with her a couple of days ago, she did another muscle port not based on open embedded patches, and according to systemd maintainers that went much better. She plans to finish that work by the mid of this year, because she's also a contractor from US, and whenever she finds time to do that, whenever someone sponsors her, and when that is upstream, and we reduce that number closely to 0, then probably we could have the systemd as a default manager. So that of course requires work and time and from all the developers and maintainers. Right, so what are some takeaways? If you need to change a tweak systemd, use package config in the VB append. For the specific machine or distro configuration, use BB appends for systemd machine units, and for configuration systemd conf, BB appends for systemd conf. And if it's tempting to override the defaults of systemd, use drop-ins because they have higher priority. Yeah, thanks to Richard, Michael for review and questions or feedback are welcome.